So there's many different LCD modules available on the market, and each may use a different protocol in order to interface with an LCD or liquid crystal display. So the underlying operation is essentially the same. At the lowest level, we're basically telling the LCD which pixels to turn on and which to turn off. And obviously, if it's a color LCD, we tell it, the RGB value for each pixel. So as well as that's having the kind of liquid crystal display, that the display modules typically have an integrated controller on them as well. So the controller contains some onboard RAM which stores the current state of the pixels. So for example, an LCD with 84 by 48 pixels may have 504 bytes of RAM. So that corresponds, we multiply this by 8, it'll give us a number of bits, and then each bit will represent 1 pixel. Because in fact, 84 times 48 will give you this value. So each bit in that RAM controls 1 individual pixel. So in high-level libraries are often used to draw text and shapes on the display. So the Nokia 5110 LCD. So this is a real, Nokia liquid crystal display you can buy. It used to be in the Nokia 5110 phones. So it's an 84 by 48 pixel monochrome display. It can be controlled using the N5110 class. So this isn't an official embed API library, if you will. This is a custom one that I've developed. So we create an N5110 object. We create using the constructor and specifying which pins to use. And the LCD actually uses SPI to communicate. So particular pins have to, the pins on the embed that have the SPI peripheral need to be used. And the library itself contains many high-level methods for drawing text, shape and sprites. So the library is a screen buffer that is stored in the microcontroller RAM. So this buffer is basically, it's a 2-dimensional array, and each element in the array represents a pixel. So when you set a 1 in that array, it corresponds to the pixel being on, and when it's 0, it's an off. So essentially, you have to set the particular values in the array to 1 or 0, depending if you want to switch that pixel on or off. And then when you use a refresh method, that will basically send that buffer, what's in the microcontroller memory, to the display over SPI, and that will then display on the LCD. So in this example here, so this is in the microcontroller RAM, and then you'll use a refresh function. That'll send it to the display, which will then turn on the relevant pixel. Some of the things, just in a simple example here, because we've got these 4 values here, we've got 1, so these 4 pixels here have switched on. So again, this is a custom library. It's not part of embed.h, so you need to include the header file from it, and then use these particular pins to initialize the LCD. So the first thing is to initialize the LCD. So lcd.init. So here I've called the object LCD. So lcd.init will initialize. It'll do various setup on the LCD, and then we can also set the contrast. So here, lcd.set contrast. So this value 0.4 seems to be a fairly decent starting value, but every display will be slightly different due to manufacturing tolerances and so on. So this value might need to be changed for different displays to get like a good contrast. So then now we've got this, once we've initialized and set the contrast, we've entered this loop. So this loop's just going to keep running. So the first thing is to clear the LCD. So essentially we've got a blank canvas now. And then we can add on different text and shapes and so on to the canvas, and then we refresh. So that will print it on the LCD. Need to leave a small delay just so our eyes have a chance to see this image, what's been displayed. Then we can go back in the loop, clear it, and update the image. So in this example here, I've actually set up another input, what's an LDR. So light dependent resistor connected to one of the analog pins. So we're going to get the value from the light dependent resistor, and then basically multiply that by, so this is a float in the range 0.0 to 1.0. So we can change it, multiply it by 60 and change it to an int. So that then will map. So in this variable width here, we'll have a value 0 to 60. And then the LCD library comes with lots of different methods you can use for drawing shapes and stuff. So we've got a draw rect for drawing rectangles. So these are the X and Y origins, the width of the rectangle, the height of it, and what fill it's got. So here, this is a black rectangle. Then we've got say a wider. Then we're drawing a second rectangle, a wider one, what's transparent. So essentially, this is rectangle 2. And then every time we're in the loop, it'll read the LDR, map that to a value. So the first time it might draw a rectangle like this. And as the light level changes, the width will change. So this is basically drawing a bar graph. So as the light level changes, the width of this bar graph will change as well. So the API, you can use set pixel. So you can turn on individual pixels, so using the XY coordinate of the pixel, and then the state, what's either true or false, so if that's the pixel is on or off. Draw circle. So again, you give it the center point of the circle, the radius, and then the fill type. So these are the different fill types you can use down here. Fill transparent, fill black, fill white. You can draw a line, so that's starting coordinates, ending coordinates, and the type of line. So 0, 1 or 2 will be just a white line, so that's basically pixels off. Black line, the pixels are on, or 2 is a dotted line. You can draw a rectangle we've just seen, so the XY of the upper left. This is XY. Then we've got the width, the height, and the fill type. You can also draw a sprite. So this is a 2D image. So that the position of the sprite, how many rows and columns there are, and then the sprite data itself. And you can also print strings as well. So you tell it what string you want to print, the starting X point of the string, and then which line. Because on the LCD, there's actually 6. It ends up being kind of equivalent to 6 lines. So you can get it to print hello world on line 1, for example. So we can print literal strings just by doing lcd.printString. So I'll start at the very left hand edge, X is 0 on line 0. But if you want to format a string, we first need to print it to a char array before we can actually print it on the LCD. So here we create this buffer. So it's 14 characters. The screen can fit on a maximum of 14 characters. So we need an array 14 elements long. And then in this example, I've just got temperature equals 27, but this could come from a sensor or whatever. This is just a value. So we're going to print. So using sprintf, that essentially creates this formatted string we've seen with printf. So whatever values in temperature will be replaced here. So in this example, it would actually be T equals 27C. So that will create this kind of formatted string, which is then stored first in this buffer array we've created. That's what sprintf does. Then we can use lcd print string, print that buffer in a certain position, and this text will appear on the LCD. So sprites are defined in a 2D array. So this is how we define a 2D array. So you can see it's eight rows and 5 columns. So essentially, this is a 2D array is essentially an array of an array. So each element in the array is a different array. So you've got this opening curly brace, closing curly brace, and then each row then you can specify the 0 ones what correspond to the pixels. So in this case, I've just made up this pattern here. So every time you see a 1, that basically corresponds to a pixel being on the LCD. So you can see all these ones here in this array. So you define the sprite in code, and we can do LCD draw sprite. So again, this is the XY position of it. 8 is the number what corresponds to here. 5. So you can change these, as you draw different sprites. Obviously the height and width will change, and then we tell it the sprite. So just because this is a 2D array, you just need to put int star. That that basically allows us to send that to this draw sprite function, and then this is a value. This is a sprite which will then appear on the LCD, so you can see that each of these pixels, so each row in here corresponds to a row which is defined in that 2D array. So that's how you can create sprites and print them on the LCD.